Alright, this is week 3's activities, and we're starting with question 4.1.1, which tells us that to calculate in Canadian dollars the difference between the price of the orange juice in January 2019 and February 2019. And this is just based off of the graph that was provided. So if we go to the graph and we see 2019 is the dotted line, and January would be over there, and February was over there, and then they just want the difference, and difference we know is subtract. So 4,3 minus 4,1 gives you 0,2 Canadian dollars. Then the next question, write down the month and the year in which the price of orange juice was at its lowest. So again, we're just going to look at our graph. And the lowest point on the graph appears to be this one over here, which we can see is in February. And according to our key, it would be 2018. So February 2018. Right, 4.1.4, determine the median monthly price for orange juice in 2020. So firstly, in order to do this, we would need to go and find all of the monthly prices for orange juice. And you can do that by basically looking for 2020, which is our solid line. And we have our different values going along here. Now, because they're wanting median, we know that we need to first arrange those values into a numeric order. So I'm going to do that quickly. Here we go. And then median we know is the middle. Now there are 12 values because there's 12 months. So half of 12 is 6. So that tells me we need to have 6 values above the median and 6 values below the median. So if I count that, 1, 2, 3, 4, 5, 6, my median should be there. And we can just check it by counting 1, 2, 3, 4, 5, 6 on the other side of it. So that tells me my median is going to be in between 426 and 427. So to find our middle value, we're going to add them together, 4,26 plus 4,27. And then we're going to divide that answer by 2. That'll tell us exactly halfway between. And that will give us 4,265 as our median value. Alright, 4.1.5 asks us to describe the trend in the price of orange juice from February to July 2018. So first, let's go look at our graph and see what's happening here. So February 2018 is the dotted line, starts over there. And we're going to go all the way to July, which is over there. And if I view the trend and follow the line, that is basically what it is doing. So 2 things we can see are happening here. Firstly, we can see from February all the way up to June, there is an increase. So that's the first thing we need to be saying. From February to June, there is a steady increase. Alright, that's the first part of your answer. Then if we look, we can see from June to July over there, it is now decreasing. So that's going to be the second part of our answer. And we say from June to July, there is a decrease. And that's the 2 points that you need to mention. Now you put this in a full sentence and you would say something like, from February to June, there is a steady increase in the price of orange juice. And then from June to July, we see a decrease in the price. So put it into a sentence, but these are the 2 points that we're looking for in order to get the marks. All right, and then our last question, 4.1.6, says that an analyst predicted that the price of orange juice would drop by 16 cents or 0.16 Canadian dollars from February to March 2021. Determine the year-on-year percentage increase going from March 2020 to March 2021. And they tell us you may use the following formula, which is our normal percentage increase formula, new minus old over old times 100. Okay, so to use this formula, right, we're going to first need to know what is the value, the new value, which would be March 21. And then we also need to know what is going to be our old value. And our old value over here would be March 2020, right? Because those are the months we're concerned with. Also notice that that is the same value that's going to go at the bottom of our fraction as well. Okay, so let's go and see from our graph, what is the value for March 2020? So if I look at my graph here, I'm looking in March, and 2020 is the solid line. So if I go up, I can see it's 4.23% or 4.23 Canadian dollars. Okay, great. So that already tells me I'm going to have on my fraction something minus 4.23. And at the bottom here again, 4.23, and the formula says times by 100 as well. Now, the March 2021, well, what do we know about that? And they tell us that the price of orange juice is going to drop by 0.16 Canadian dollars from February to March 2021. So let's go and see what the February price is. So again, I'm going to look at my graph here. And February 2021 is going to be in this, again, dotted line. And we can look up here and see where is February 2021. Now, you are going to have to estimate a little bit here because we don't have the exact value. So if I'm estimating, the way that I'm doing it is I'm starting by going, well, halfway between the two values would be approximately there. Right, and you would use a ruler on this to say, well, this would be 4.45, which is halfway between 4.4 and 4.5. So now, if this is slightly above that line, we can estimate it to be approximately 4.46. I wouldn't go any higher than that because it is quite close to that line. If it was higher up, then maybe I'd go up to 4.47, but 4.46 would be approximately, right? You are normally allowed about 1 decimal point for if you make a mistake with the estimating, but it is very clearly not 4.45. So I wouldn't accept if you said that, but slightly higher is fine. Okay, so that tells us that in 2021, we were sitting at 4.46 in February. And they did tell us that there would be a decrease by 0.16. So we take off our decrease, we're going to get 4.3. And then that's the value I'm going to use in my formula. So I'll just take that and write it into my formula there, 4.3. Okay, and then all that you have to do is pop that into your calculator as a calculation, and you should get to a final answer of 1.65%. And that is the answer to 4.1.6. Question 4.1.1, we've got the seating of a cinema. And the first thing they want to know, on which side of the cinema is E4 from seat E15 when a person is facing the screen. So let's find where those are. So the person is sitting in E15, which is over here. And they're asking where is E4, which is over there. So if I'm sitting, I'm facing towards the screen, which means I'm facing that way. Then E4 would be on the right hand side. And that's all you needed to do, say right hand side. Okay, 4.1.2, assume that pre-COVID-19 conditions apply and all the seats are now occupied. Name the row and seat number in the middle of the 8th row from the screen. Okay, so we just need to count back 8 rows from the screen. So row 1, 2, 3, 4, 5, 6, 7, 8. So 8th row is actually our back row, the K row. And then they want us to say in the middle. So in the middle, we can see we have 21 seats altogether. Get a different color. 21 seats altogether. You could just count, and you could just go, okay, count off this one, and kind of work your way all the way through until you get to the middle. That would be one way of doing it. The other way of doing it would be to go, well, half of 21 is actually 10 and a half, which means I should have 10 seats on each side. So if I do that and I just count, I go, okay, well, we've got up to 7, 8, 9, 10. That would be my middle seat, because then I should be able to count 10 on the other side, and you can just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So therefore, the row in the seat number is going to be row K, seat number 11. All right. Next one says, write down the ratio of the number of wheelchair spaces to the number of seats for patrons who are not in wheelchair. Okay, well, if we look at our little key, our wheelchair spaces are the ones with the little wheelchair in them, and we can see there is 1, 2, 3, 4. So we already know that that's going to be the first part of our ratio. And then the number of non-wheelchair seats, you can go and count them for yourself, but you would get to 130. So 130 seats. And honestly, I would count that by going 21, 42, and just kind of keep going with that. 63, 84, 105, 126, and so on. And you can count your way up. The important thing to notice with this is that if you're doing that, you also need to take out the aisle seats over here that are not being counted. So you need to take out 3 times by the 7 rows over here. And you also notice that these rows over here don't start at 1. They actually start at 4. We also have an additional seat over there that is row 0 for purposes. It's before 1. So just be very careful with these type of diagrams that you are counting accurately with that. And then we just need to simplify our ratio. And we've got 4 is to 130. I can divide both of those by 2. I can go 2 is 65. And I can't actually simplify any further than that. So that would be my final answer. Alright, and then our last question here for the sub-question. We've got on Friday evenings pre-COVID, all the seats in the cinema, excluding the wheelchair spaces, were occupied. Calculate the percentage of income lost due to social distancing during the pandemic if all the tickets for the seats are equally priced. Okay, so the idea here is we need to know, well, how many seats are vacant, and what is that as a percentage of the total seats in the cinema. And they do tell us to exclude the wheelchair, so we don't have to worry about those. So if you go and count all of your vacant seats, and they're all these like 0, all these X's right there, and you can kind of count all of the X's, you're going to get to a total of 66. So we have 66 vacant seats. We know from our previous question we have 130 seats altogether in our cinema, excluding our wheelchair seats. And then we want a percentage. Now, I know they say here percentage of income, but percentages work across. So if we're talking about percentage of income, we can also just talk about percentage of seats. Imagine each seat was 1 rand. Then you would work out by saying, well, if every seat was 1 rand and they sold all these seats pre-COVID, they would have made 130 rand. And then if during COVID they were still 1 rand, but 66 of them were empty, 66 would be the part that is not being earned. They're losing 66. Then we just times it by 100 to make it into a percentage, and we're going to get to 50.77%. All right, and that would be their loss, which is what's being asked. Okay, remember, if they were asking percentage of income that they're still earning, it would be the reverse. Right, let's go to 4.2. Alright, 4.2.1 says state the purpose of the breathing valve on the tank. Okay, admittedly, this is a bit of a general knowledge question over here. And we know this is diesel. Diesel is a type of petrol, and we know there are fumes involved when you've got chemicals like petrols and diesels around. So the purpose of the breathing valve is just to allow for air or chemical fumes to escape through the top of the tank. So the main thing we're looking for here is to release air or to prevent the tank from exploding by containing the fumes within it. 4.2.2 says the steel used to make the tank is 5 millimeters thick all around. For safety reasons, the tank is filled to 95% of its capacity. They want us first to show that the inner diameter of the tank is 3.21 meters. Okay, so let's see what we know about this. The first thing we need to look at is, what do we know about the diameter? Well, we know the diameter of the outer tank is 3.22, right? And they also tell us that the steel is 5 millimeters thick. So, technically speaking, if we were to take this tank, I'm going to try and draw it on the diagram here, all that we would be wanting to do is, rather than starting right up here, which is in line with the outside, we want to pull it slightly lower down to allow that gap for the metal of the tank. And again, over here, because we're wanting the inner, we want to remove that gap, that difference of the metal. And the metal, they do tell us, is 5 millimeters thick. Is it millimeters? Yes, 5 millimeters thick. So we know that we need to take away from this the 5 millimeters. So we're going to go 3.22 meters minus. Now, we can't minus millimeters from meters. So we need to convert 5 millimeters divided by 1,000 is going to give me 0.005 meters. So minus 2 times 0.005. The 2 is because obviously the metal is at the top and the bottom of the tank. And that will give us 3.21 meters. That is your answer for A. Okay. Question 4.2.2b. Calculate the maximum liters of diesel that the tank can hold according to safety regulations. And they give us a formula for volume. So that tells me we're going to need to do something with volume. They want liters of diesel. Well, what do we know about liters of diesel? And if we look, this in a color, liters, we know that 1,000 liters is 1 meter cubed. Now, that kind of ties in with this idea of volume because they've given us a volume formula. So in theory, if we can figure out what is the volume of this tank, then we can work out how much diesel is actually in the tank. And then we can work out the formula. So, we need to start by finding what is the volume of this tank. And all that we're going to do is substitute in our values into our formula that we already have. So let's see. Volume of cylinder, oops, it's going to pen. Volume of the cylinder is going to be 3,142 times by radius squared. Now the question is, what is our radius? And because we're talking about what's going into the tank, we know we're going to use our inner radius, not the exterior one. So if the diameter, which they tell us over here, is 3,21, our radius is going to be half of that, 3,21 half. That is now my radius squared. The height is the next thing that we need. And in this case, when we're looking at this diagram, height is not actually technically height. It's because the cylinder is on its side. Height has to do with this long length going across here. But we again have a problem because these measurements are our outer measurements. We need our inner measurements because we're talking about how much liquid can fit into the tank. So we again need to take off that little gap for the actual metal on each side. So really, the length that we're going to work with is not going to be 7,25. We're going to go 7,25 minus 2 times 0,005. This is exactly the same as what we did to find our inner diameter in the last question. And that'll give us 7,24 meters. So that is actually, when they're talking about height, remember height in the formula for volume can also mean depth, can also mean length. It is basically the space between the two matching sides. So the two circles, the space between them. Okay, so then when I'm going to multiply by height, I'm going to say times by 7,24. Okay, now that we can just pop into our calculator, and we're going to get to 58,599 6227 82. Okay, and that's in meters cubed. Now the next thing we need to remember is they're wanting to know about liters of diesel, and they do tell us in the question that the tank is only filled to 95% of capacity. That means that we don't need to work out for 58 meters cubed. We actually need to work out what is 95% of 58,599. The whole number there. And if you do that, we're going to get to 55,66964, and it kind of keeps going from there, meters cubed. Okay, great. So that gives us now what is the volume of the diesel in the tank. But they want it in liters, so here's where our conversion comes into it. And this is using that 1 meter cubed is 1,000 liters. So that means I can just multiply it by 1,000. Alright, so I'm going to go 55,66964. And the whole long number, remember, I'm not cancelling it off my calculator. I'm just doing the dots for the sake of space. Times by 1,000 will give me 55,699,64 liters, and therefore you can approximately round that to 55,699, oh, not comma, sorry, 55,699,64 liters. Right? Remember, you always show it unrounded first before you round to decimal places. Alright, 4.2.3, the external surface area of a tank, excluding the base and the external attachments, needs to be painted. The spread rate of the paint is 3 meters squared per litre. The manager states that he would need less than 30 litres of paint to complete the task. Verify, showing all calculations whether or not he is correct. And we know when we see verify, that tells us we need to know, give a statement to say, will they need less than 30 litres of paint? Okay, so this tells us already that we're talking about surface area. And we are actually given the formula for surface area of a cylinder. I haven't got it typed here, but I'll write it out quickly. They do give it in the paper. We're told that the surface area is going to be 2 times 3,142 times by radius plus height. And they do tell us the R is radius and the H is height. So the first thing we're going to need to do is work out what is the actual surface area of this tank. So we're substituting in here. The 2 can stay, 3,142. The radius is half of 3,22, so 3,22 divided by 2. Okay, we're using external measurements now because we want to work with the outside that's going to be painted, into 3,22 divided by 2 to find the radius, plus the height of 7,25. Okay, and this radius we can just rewrite as being 1,16 as well. 1,61. So I'll just write that out. 2 times 3,142 times 1,61 times by 1,61 plus 7,25, and that will give us 89,64 meters squared, because it's surface area. Now, they do tell us in the question that they don't want us to paint the stands, the base stands, and we can see there in the picture we've got our 3 little stands at the bottom. We are told here that the base area of all these external attachments is 1 meter squared. So that's pretty easy because it's telling us we don't need to paint the 1 meter squared. So therefore we're going to paint, and I'm going to just label it to paint. We're going to say 89,64. Oh, my pen's not working there. Let's try that again. 89,64, and we're going to take away 1 meter squared, giving us 88,64 meters squared. Okay, now we need to work out how many liters are needed based on this space that we're actually going to paint. And if we go back to our question, we are told that the spread rate is 3 meters squared per liter. So that's pretty easy, because we can go, well, look, we know 3 meters squared is 1 liter. I need 88,64 meters squared. How many liters? And it's up to you whether you can see, okay, you need to divide, or you can just go divide up, multiply across, and you're going to get to 29,55 liters. Then the last thing we needed to do is say, is the statement valid? And to remind us, the statement was saying, he says he will need less than 30 liters. Is he correct? Well, this is less than 30 liters, so we can say therefore it is correct or valid. Right, our last question, 4.1.7, tells us that an analyst's prediction for the price of orange juice for for the rest of the year is shown in table 3 below. Use the answer sheet to complete the line graph from March to December 2021. Alright, so this is fairly straightforward. We're just going to graph. And so we're just going to start with April 4,25. So we got April 4,25, which will be approximately halfway over there. Then we're going on to May, which is 4,28, which is going slightly higher over there. And I'm using my reference points as this 4,27 over here, right? I know 4,25 will be exactly halfway between these two lines, okay? Because this is 4,2 and 4,3, so 4,25 must be in between them. Then I've got 4,28, which must be slightly higher than 4,27. That's why I've placed it over there. Then my next month is going to be May, and according to my table, sorry, not May, June, should be 4,3. Okay, well that one's easy because it's straight on the line, and I'm just reading it there. And you basically just keep going, plotting each of the points all the way across. July 4,05, which is going to be down here. The 05 is, and where you've got 5 in the third decimal place are easy because we know it's halfway in between. August 4,35, 4,35 is going to be there, and so on and so forth. September 4,2, 4,15, 4,27. This one is nice because it's in line with the other 4,27. You can actually just take a ruler and kind of dot your way across to check if you get there or not. And then my last one is going to be 4,2 again, so I just put the dotty. And then I need to just continue drawing my line graph. Okay, so obviously you would be doing this with a ruler. It is a dotted line, so I'm just going to continue on with my pattern of a dotted line going down. So I think I need to make my screen a bit bigger for the purposes of this. And you just basically following the dots. Be careful you don't miss one out like I just did. First we need to go down all the way down to there, and then all the way up like so. Okay, obviously this is easier when you're doing it on a piece of paper with a pen and a ruler because you can just join up your dots with a ruler, but that's the idea behind what your line should be doing. Okay, and then you have your final line formed there. This was a 4-mark question. Typically when you've got 4 marks for something like plotting of points, it is going to be a case of you're getting a mark for knowing to join the points, and then you get a mark for every 2 to 3 points that you have correctly. And that's the end of week 3.